Welcome to David Alexander Maths Tuition. This is Chapter 2H, Modelling with Quadratics. So a goalkeeper kicks a football where the distance in metres of the ball from the ground, y, can be modelled with the quadratic equation (-x squared plus 3x plus 1.5, where x is the time in seconds from the moment the ball is kicked. Okay, so a minus x squared graph is it's not your usual U-shaped, it's an N-shaped graph. And if you were to kick a ball, then I guess that would be a realistic profile. It seems quite reasonable. Okay, so how far from the ground is the ball at the moment when the ball is kicked? So x is the time in seconds. Now, at the moment the ball is kicked, time hasn't started yet. X is the time in seconds from the moment when the ball is kicked. So when it's kicked, x equals 0. So if I put 0 into this equation, so minus 0 squared plus 3 times 0 plus 1.5, we just get 1.5. So y is 1.5, which is the distance in metres of the ball from the ground. So that is how far the ball is at the moment when the ball is kicked, 1.5 metres. So quite often this value here is the starting value. Okay, let's see part B. How far from the ground is the ball after 1.3 seconds? So x is the time in seconds, so all I need to do is substitute 1.3 into the equation. So it's minus 1.3 squared plus 3 lots of 1.3 plus 1.5. Okay, so what is 1.3 squared? That is 1.69, so minus 1.69 plus 3 times 1.3 plus 1.5, the answer is 3.71, so 3.71 metres. On to part C. How long is it until the ball reaches the ground? Okay, so y is the distance in metres of the ball from the ground, so I need to make this equation, set it to 0. Minus x squared plus 3x plus 1.5 equals 0. So I'm going to use my quadratic equation solve where a is minus 1, b is 3 and c is 1.5. So menu setup, minus sign, polynomial 2, degree 2, minus 1 for a, 3 for b and 1.5 for c. And I'm getting 3 plus root 15 over 2, which is 3.436. Let's just call it 3.4 seconds. And if I press equals again, I'm getting another solution, which is minus 0.436. But of course, it can't be a minus value for time. We're not going back in time. So here the answer is 3.4 seconds. What is the maximum height from the ground the ball reaches? Okay, so the maximum height is this point here, which is the turning point. So what I need to do is to complete the square. Now I can only complete the square on an x squared, not a negative x squared. So I'm going to have to factorise through by minus. I'm going to have to factor out minus 1. So that's minus lots of x squared minus 3x minus 1.5. So that's going to be minus big bracket, little bracket, x minus 3 over 2 all squared, minus 9 over 4 minus 1.5, close the big bracket. What is minus 9 over 4 minus 1.5 is minus 15.4. So that's going to be minus, big bracket, little bracket, x minus 3 over 2 all squared minus 15 over 4. Now I'm going to get rid of the big bracket, so I'm going to expand the brackets with this minus 1. So that's going to be minus x minus 3 over 2 squared plus 15 over 4. So the turning point is 3 over 2, 15 over 4. So what that means is after 1.5 seconds, the ball reaches its maximum height, which is 15 over 4. So 15 over 4, and if you want, we can just turn that into a decimal, so that is 3.75 metres. How long after the ball is kicked is the ball at a height of 3.2 metres? So y is the height, so we want to set our equation to, so we know that y equals minus x squared plus 3x plus 1.5, so all we need to do is therefore set minus x squared plus 3x plus 1.5 to 3.2. Okay, so let's just subtract 3.2 from both sides, so minus x squared plus 3x, and what is 1.5 take away 3.2? That is minus 1.7 equals 0. Again, I'm going to use my quadratic equation solver where a is -1, b is 3, and c is minus 1.7. So menu setup minus polynomial 2, degree 2. So minus 1x squared, 3x minus 1.7. So I'm getting x equals 2.2416 and x equals 0.758. Okay, so maybe the question could be worded better, but the first time it reaches a height of 3.2 meters, let's say this is 3.2 meters here, is after 0.758 seconds, but it also reaches 3.2 meters on the way back down again after 2.2416 seconds. So I would imagine that for this to be a slightly better question, we should probably put in the word first, or they could be saying how many seconds does the ball spend in the air at a height that is greater than 3.2 meters or more. That would be the difference between these two values. But let's assume that for this question it's when is it first at that height of 3.2 meters, so that is at 0.758 seconds. But then again, on the way back down it does reach 3.2 meters after 2.2416 seconds.